Hello, everybody. We're starting in on week 3 of our solitary confinement out of school. Hope everybody's doing well. I miss being at school with everyone, and sorry that the situation appears to be taking a little longer than everybody thought. So hopefully, we'll be able to get back soon. But in the meantime, we're going to continue on, and we're going to start chapter 17, which deals with waves. And in this section, we're going to deal with one particular kind of wave, which is mechanical waves. The other kind of waves are going to be electromagnetic waves, and we will discuss them later. Mechanical waves, any wave is really just a disturbance. It's a vibration, and energy is carried in waves. You can't necessarily see them, but you can see or feel or hear the result of the wave. Mechanical waves are different than electromagnetic waves in that they need matter through which to travel. So like light is electromagnetic. It can travel through the air. It doesn't need anything to travel through. But mechanical waves do. And the whatever the waves travel through is called a medium. So if you look at the picture of the tuning fork at the bottom of the screen, anybody who plays the piano or is in the band is probably aware of what a tuning fork is. When you strike the tuning fork, which is metal, it causes a vibration in the metal, and the metal produces a tone. And that tone is used to tune a piano or to get all the different members of a band in tune together. And you can see that in the animation that the tuning fork doesn't wiggle that violently back and forth. You can't see it move. But if you have your hand on it, you can feel the vibrations, and the vibrations move in a scatter plot, kind of like what you see in that diagram. There are 3 types of mechanical waves, and that has to do with the way the wave moves. A transverse wave, a longitudinal wave, or a surface wave. And a point somewhere in the wave is going to move up and down or side to side, but there is going to be movement. There's going to be vibration, and we call it a wave because there is a maximum height to this movement and there is a minimum height to the movement. You can see again in the diagram that a wave is traveling up and down like we do a wave at a football game. People go up and down, and the height of the wave is going to be called a crest, and the bottom of the wave is going to be called a trough. And a wavelength is the distance between one trough and the next, or one crest and the next. Transverse waves are waves that cause the vibration to move at right angles to the direction of the wave. So if we have a wave moving, in this case from left to right, the movement of the wave is going up and down. So it's at right angles to the direction of the wave. If you've seen little kids playing jump rope, and they have a rope and they're wiggling it back and forth on the ground for people to jump over, that's much of what the movement of a transverse wave looks like. And as I said before, the peak of the waves are called the crest. The bottom part of the wave is called the trough, or the lowest part. And the position or the distance between 2 crests or 2 troughs is called a wavelength. And these waves are carrying energy. The second kind of mechanical wave is called a longitudinal wave. And this type of wave, the movement doesn't go at right angles, it goes in a parallel direction to the motion of the wave, or the direction of the wave. This is best shown by a slinky. If you have a slinky, you hold one end and you have someone else hold the other end, and you push it toward one another, you can see the wave travel down the slinky. Parts of it will become close together, and then they will relax and separate. And the scatter plot kind of shows what the movement of that wave will look like as it travels down the slinky. Where the slinky wires come close together It's called a compression, and you can see that's where the darker parts of the dots on the animation, those would be compressions, and where they're spread farther apart and it's not quite so dark, those would be rarefactions. So where it's more spread out is a rarefaction, where they're closer together, it's a compression. And the last kind of wave is called a surface wave. And when you did your experiment on Friday, dropping water into a container holding water, you could see waves. You could see waves emerge from that droplet as it fell into the water. And there's a separation. If you look at the animation here again, you can see the top of the water is moving, but the bottom is not. Or the top of the diagram, the dots at the top are moving, the dots at the bottom are not. And the motion is in a circle. So if you've ever been fishing and you have a bobber at the end of your fishing line and it's sitting in the water, the waves go through it and that bobber doesn't move. It moves in a circle. It really doesn't go anywhere. It stays kind of where it is. So that's pretty much it for the first section of the chapter. There's some terminology. Anything that was underlined on the slides you need to know. And I want you to be able to answer these 4 questions. So for your homework, answer these 4 questions onto a Google Doc and submit it to me by midnight tonight. And then please read the second section of the chapter for tomorrow. And we will talk again tomorrow. Have a great day, and don't work too hard. Take it easy.